Okay, hi guys. So in this lecture, we'll be starting off with a new topic, which is alcohols and ethers. I know the name is pretty much familiar to all you guys, but we'll be seeing some more complex mechanisms in this chapter. Okay, so let's get started. So we have alcohols and ethers. Okay, so suppose we have a secondary alcohol and we want to convert it into some ketone. Okay, so such type of reactions will be dealing off in this chapter. So we'll be dealing with some of the reactions like hydration of alkene and we'll be seeing something like HBO. Okay, we'll see the full form afterwards. OMDM. Okay, diazotization, reaction with RMGX, Grignard reagent, reduction reactions. Okay, and we'll also be seeing something like hydrolysis of ether. Okay, so let's get started with our first example, wherein we have something like alkene. Okay, alkene on reacting with, or rather hydrolysis of alkene, we'll have something like, we can also use HBr. Okay, in presence of water. Okay, we'll get something like a carbocation. Okay, this would be obviously the redetermining step. Okay, and then afterwards water molecule will be attacking on the carbocation, and as a result alcohols would be formed. So what did we use? We used alkenes, and what actually formed? Alcohol. Okay, so what happens when we react this alkene with HBr in presence of CCl4? We'll get something like, again, a positive charge with hydrogen attached on this carbon atom, and then Br minus will actually attack on this carbocation and add itself to the carbocation, and a halide would be formed. Okay, rather alkyl halide. Okay, what happens if we react this compound with, and we hydrolyze this compound? What will happen is positive charge will come here. Okay, and now ring expansion will take place. Okay, I hope you remember the ring expansion, wherein this bond will be broken up to create positive charge at this carbon atom and attach itself with this carbon atom. So let's suppose this is the second carbon atom. We'll have something like positive charge on the this carbon atom. Presently we have 1 2 3 alpha hydrogen for this positive charge. If we actually do another H minus shift, okay, we'll get something like this product with positive charge here. Okay, how many alpha hydrogens does it have? 4 plus 3 7. So this is more feasible, hence it will go into the forward direction. Okay, next what will happen is water molecule will again be acting on this positive charge, and we'll get something like OH here. Okay, let's discuss third example, wherein we have something like this. Okay, what will happen here is, again, if we hydrolyze it, positive charge carbon atom will come first onto this position, because alkene will add hydrogen at this position, so hence this position will get positive charge. As a result, we'll be getting something like this and CH3 here. Next, what will happen is H minus shift, or rather CH3 minus shift will happen. Okay, and this CH3 would be migrating to this carbon atom or carbocation. As a result, we'll be getting positive charge at this carbon atom. Okay, and next what will happen is hydrolysis, or rather hydrolysis will happen, in which water molecule will attack on this positive charge. As a result, we'll be getting something like this, and H plus would be removed. Okay, so let us take another example where we have something like this compound. Okay, and we are again doing its hydrolysis. What will happen on doing the hydrolysis? We'll get positive charge here, let's say. Okay, even if we get positive charge at this carbon, these are both identical. Okay, you can rotate this in this plane at 180 degree, it doesn't matter. Okay, so now what will happen is H minus shift will again happen. As a result, positive charge will come on this carbon atom, and because of this coming positive charge coming on this carbon atom, it would be resonance stabilized. Okay, next what will happen is hydrolysis will happen, in which H plus would be removed from the attacking water molecule and OH would be formed. Okay, and obviously benzene ring is also attached. Okay, so this will be the final product formed. Let's take another example. We have CF3 CH double bond CH2. Okay, so obviously this is more positive, this is having more partial positive charge, this carbon atom, than this carbon atom. Why? Because of the attachment of highly minus I group nearer to this carbon atom than to this carbon atom. Hence, on attack with or hydrolysis in acidic medium, what will happen is H will be getting attached here. As a result, we'll be getting positive charge formed here, and in presence of water molecule, minus H plus will take place from the oxygen atom, and we'll get something like CH2 CH2 OH. What if we actually do HBr in presence of CCl4? Then our chief product or the major product would be something like this. Okay, so let's also discuss some reaction which is called aromatization. Okay, so what actually happens in this reaction is, suppose we take an hexane, okay, and we react it with Cr2O3 and Al2O3, and we heat this. What will happen is this N-hexane will convert itself into a benzene. Okay, if we take similarly, if we take N-heptane, again in the presence of Cr2O3 and Al2O3, if we heat it, again it will form a toluene. Okay, and third, if we take something like N-octane, okay, again if we react with Cr2O3 Al2O3 and we heat it, we'll get something like either this, or we'll get something like this. Obviously we can rotate it in orthometa para combinations and get more results. Okay, so with this we come to an end of this lecture. In the next lecture we'll be continuing on seeing some more concepts on alcohols and ethers and some more reactions on the same. Okay, so please remember, before ending this lecture, I would like to tell that please remember this aromatization reaction. It will be useful in some of the JEE level competitive examinations. Okay, we will not be discussing the mechanism as it would be OOS or similar out of syllabus. Okay, just remember this reactions, and do keep revising these reactions so that it becomes a part of your permanent memory. Okay, so till then, good luck and goodbye.